right, welcome back, generals, to another Let's Fix the Generals 0 Hour to make the best game ever. Okay, last session we have tried to collect virtual functions to overlap them, but we had great difficulties. But we made discovery about the virtual thunks. It looks like they should help us get additional information on the pure virtual functions that don't have names, where we need to assign names. Okay, so we said first we should collect those secondary vtables. No, first we need to collect all the virtual thunks. There we go. These ones here. First we need to figure out which type it is. Let me see. Non-virtual thunk. There we go. It is raw type 30. Raw type 30. Do we have that yet? 30. Raw type 30. Hold on. Let's open the calculator. Decimal 30. It's 1e. Yes. 1e. We did look at 1e, which is this one. PEXT. Right? Let me see. It's this one here. 1e. 1e, yeah. I do wonder, are these virtual thunks posted before the vtable or not? Oh, no, they're behind. Oof. Okay, so I think what we need to do is we first need to yeah, we probably need to make another iteration. I think we can put that here. Here. How about we call this parse PEXT and then non-virtual thunks. Is that a good name? Non-virtual thunk. How about we just call it thunks? Thunks. Okay. And then here we call this RTTI. Okay. I hope that naming makes sense. Okay, so basically we will have this and then we make a thunks. I don't know if we need the binary, but let's keep it for now. And then we put this up here. Oops, that didn't work. Let's copy just this, yeah. There we go, thunks. Okay, Okay, and then we say um, mm, mm, mm. Text call, non-virtual thunk. Those non-virtual thunks, they probably have a prefix, right? This one, ZT. No? Let's see. ZTHN 96. Four. ZTHN. Oh. ZTHN. Okay, so my suspicion is that it always starts with ZTHN. So I would say put that here. If starts with ZTHN, then that will be our non-virtual thunk 2. Non-virtual thunk 2. Dot 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 vtable for dot dot dot. Okay. Non-virtual thunk 2. And then what do we do in there? Hold on. By the way, let me make sure. Yeah, let me hide this thing here. Okay. Okay, so yeah, we need this thing here, and then basically we say yeah, call this, and then thunk name. There we go. And then erase. We erase this. Erase. Yeah, basically, how many characters are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. 21. Okay. Okay, and then so I don't think we need this binary thingy here. Okay, so let me put a breakpoint here. I want to see if there are hits and what that looks like. I think we need the address and we need the name. That's about it, right? There we go. Okay, so it has a section. Section description 80. Value is, that's the address. And that's it, right? Yeah. Okay, so I think what we simply do is in our CPP types, we create a new here. Let's call it struct non-virtual thunk. There we go. And then we simply put a name and an address. std string name and address. Do we care about the mangled name? Probably not. Okay, then we take this guy, non-virtual thunk, and we put it up here, and then we create a new here non-virtual thunks. There we go, non-virtual thunks, and then we take this guy and we put it down here. There we go. We call it just thunks. Keep it short. And then here we create a address to index map address to thunk index. No, address to thunk index, and then we create a new function here. Find or create non-virtual thunk by name. Find or create non-virtual thunk. Do we actually use this function? Find or create function by name. Do we actually use that? We don't. Where do we have it? I know where we use the other ones, but we don't use this one. I wonder if we should remove it. Name to function index. Where do we set this? Set it here. Yeah, I mean, if we don't call this right now, let's comment this out. And so I think here for the non-virtual thunk, we should create it by address. Actually, do we actually need a function? Maybe we don't. Let me remove that for now. Yeah, let's just go to our... let's go to, where is it? Here, thunks. And we simply say m address to thunk index. Address to thunk index find symbol dot value thunk address to index map iterator it, and we expect that there's no duplicates, right? Assert it equals end, and so then we expect we expect non-virtual thunk. We create a new thunk, and then thunk dot, oh, what happened? Thunk dot mname equals thunk name, and thunk dot address equals this one, and then we simply do thunks dot push back. What we do, yeah, push back std move thunk, and then std move thunk name, and then address to thunk index dot emplace symbol dot value, and thunks index t index equals thunks dot size -1 index vector const. All right. Okay, that would be pretty much it. Maybe we need to shorten the name as well. Maybe not. Maybe it's fine. Okay, let me see what this does. Okay, I think we can remove binary. So we have this non-virtual thunk to that. Now we erase this. See sample sound 3D idle. Okay. Then this one should return the end. And then we create a new this address pushback, and index is 0, and emplace this address to index. Yeah. I think that's it. Yeah. Okay, that was simple enough. So when this is all done, how many thunks do we get? Let's see. Oh, that's not much. E0D, how much is that? Hold on. 3056. Yeah, actually it makes sense. 3000. Yeah, this looks like a reasonable number. Yeah. Yeah, seems plausible to me. Okay, and then good. So next step will be to to pass the secondary vtable here, which is here, end of primary vtable, beginning of secondary vtable. So we should not skip it, but we should actually use it. Okay, how do we do that? Okay, so basically we have an offset here, and in our base classes we have stored, hold on, base class, here we have the base offset in bytes. Oh boy. I hope that the secondary vtables can only contain non-virtual thunks, or can they also contain something else? That's a question I have now. Well, I guess we will figure out once we start parsing. Yeah. Okay, so we probably need to say okay, before we think about this, we also need to think about where do we store the thunks. Oh boy. Well, before we store, let's parse first to see like what we actually need to store. Yeah. Okay, so End of primary vtable. Begin of secondary vtable. So okay, I think what we need to do is let's take an integer offset to this. By default, it's 0. Offset to this. Okay, let's put it up here. Offset to this. Offset to this. This one is UN32T. Offset to this. How about we make it an in32T actually? In32T. Offset to this. Offset to this equals this one. Okay. And then basically here we say vtable info. Okay, how about here we say if this is the case, continue. Basically here we need to say we change vtable info to vtable function address I. No. Maybe that's not a good idea. How about we do a O equals 0 plus plus O. Then here we do O. Then here we do I equals 1. Oh, is this correct? Oh, I equals 0. This one here is a bit of a problem for what I want to do. So basically I want to reset the vtable info. Okay, so basically offset to this, we would change here. Actually, we don't need this anymore if we change this offset to this 0. So basically we want to change vtable info here. Vtable info. And it's meant to be changed. Can we do this? Don't think so. I don't think so. Yeah. Actually, we can, I think. I think we can do this. I hope. No, maybe. Okay, and then I would be 1. No, I would be 0. We start at 0. Hold on. We start at -1. And then it goes to 0, essentially. Right? I hope. Mm-hmm. 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 Yeah. And then we need to say, we need to have a const. Oof. Const. Not a const. Oh boy. Int vtable count 1. No. This one is the first. Let's put it here. Vtable info, vtable count 1. Okay. And so here, do vtable count times this plus, why is this -1? Oh, -1. I'm not sure why it's -1. I think here we need to say O minus equals 1. Why is this? Don't I just say times O? I'm not sure. Let's leave it for now. Okay, but this could be correct. Vtable count. Hold on. We need to plus equal 1. Okay. End of primary, begin of secondary vtable. Okay, and then here we would say if vtable count equals 1, then we do this stuff here. Else, let's say this is primary vtable. And this is secondary vtable, non-virtual chunks. Secondary vtable containing non-virtual chunks. Okay. For now, let's put here an int a equals 0, so we can put a breakpoint in here. Let's also put a breakpoint in here and see how that goes. Okay, so symbol value plus size. Oh, how about symbol value? Where's this thing? Symbol value. How about we call this just address const const. What does this return? uint 64t va equals, or we just call it address. Address. Symbol address. instead of calling this every time. Okay, I hope that this is correct. I'm not so sure about the O minus 1 here. This makes sense to me. O minus 1. Why minus 1? I'm not sure, but maybe it's correct. No. Though it's weird because I would expect it's O, 0. I would expect it's just O times O. Okay, let's see what this gives us here. Yeah, let's see. Okay, so we get this hit. That's good. Okay, so this thing equals this. That means so offset to this. Now this should change to minus something. Type info should remain the same. And then we get new function addresses. There we go. Offset minus 40. Type info is the same, and then some function address. Yeah, this looks good. This looks good. Okay, so vtable count then increases. That's good. I will change to minus 1. O will change to will be decreased. Will be decreased. Yeah, I hope that's correct. Okay, and then we continue, and now I should be 0, yes. Okay, function address, okay. Let's put that a hexadecimal. That looks like a decent address. And what now? Function address not 0. And now we should go here into the second one. Yeah, okay, so this looks good. Now, next thing, we will do this one, address to index map. Address to, so we will do address to thunk index, thunk function address, it. We also put an assert here, address to function, address to thunk index, and then we do yeah, we just do thunks and it second, and then we do thunk. There we go. Okay. Okay, then we check what we get there. Okay, let's put a breakpoint here. Okay, so basically I'm now interested if we hit any asserts. If not, great. If we do, we need to check what is wrong. I'm still suspicious about the O -1. Okay, let's see. So this one returns a result. That's good. And will give us a thunk. There we go. Looks like a destructor. Okay. Then let's run it through and we get an assert. Okay. Okay, what do we got? That's what I was being afraid of. Well, not afraid, but there was a chance. Okay, what do we got? Aha! So there is a pure virtual in there. Yeah. There's a pure virtual. Okay. 3FF004. Okay, so it means there can be a pure virtual in there. Yeah. So this one here. Okay. Okay, then that means we need to create a vtable entry. I think we can just make a copy of this thing and we put it here. Yeah. By the way, we wanted to remove this binary thingy here. Oh. Okay, containing non-virtual thunks. Okay, so pure virtual. Okay. Well, maybe we should put this outside. Maybe. Maybe not. Let's go with this for now. Yeah. Okay, let's see what assert we hit next. Maybe we need something similar to this. Right? Yeah. Maybe. Okay, let's see. Let's see. My expectation is that we hit the assert again for something similar to this here. Yeah. There we go. 6.5 EC. 6.5 EC. Okay, where are we? We are at radar. Let's get to the symbol address. This one. Copy value. There we go. Uh-huh. 6.5 EC08. So I think we are looking at this one here. 6.5 EC08. It's that one. Yeah. Okay. Huh. Init. I don't know what this means when we have these functions in between there. What does that mean? I don't know. Non-virtual thunk. I'm not really sure what this means, that we have these in between here. Post-process load. Virtual. Post-process load. Subsystem interface. Aha. Aha. Okay, so we see that init reset update, they refer to these. And then in here we have this and draw. Yeah, okay. Okay, let's non-virtual thunk. Non-virtual thunk. Okay. Okay, I would say we do the following. We say if vtable count is larger equal 1, or if vtable count is larger equal 2, if that is the case, then we do on top, we do this here. Yeah. This here. Move this here, and then we need to change this stuff here. Yeah, and then this is always the fallback stuff. This here, yeah. Okay. Okay, let's, but this now should work without asserts, I think. No? Hold on. Here we need to say if it is not this dot end. There we go. There we go. Okay. Okay, but this should now complete without asserts, I think. But we need some additional stuff here and then here. Yeah. Let's see. Okay. Oh, hold on. We need to put continue here. Continue. Yeah. And we need to put this here. Maybe we can remove this condition here. We can put assert vtable count. There we go. There we go. Okay, so this should now run through without asserts, I think. Let's see. That works. Okay, then we can work with this. Okay, so basically, let's delete this here. Okay, so basically, we now need to say, yeah, basically we need to put the thunk somewhere. Right, so let's see. Okay, how do we do it? I still don't understand why it's O-1. Let's put a breakpoint here and see if it hits. It needs to hit once. Right. It was something with 44 ending or something. Yeah. 7544. My memory does not fail me. Okay, if that works, it works. Yeah. Good. Where are we? Here. Okay, so then I don't think we need this assert here. Okay, so we need to say secondary vtable contains non-virtual checks among others. Okay, so I think what we have to do is in our classes we have those base classes, and in the base class I think we should also put the vtable. So for some reason I cannot move it. Why? Why can I not move it? Now I can move it. So I think in our base class we also put a vtable. Not everyone, not every base. Oh, hold on. Yeah, actually, no, it's correct. Was it not? It has base class? I think so. Yeah. Is virtual vtable. I wonder if then this vtable should be in the first base class. Not sure. Let's hold on. How about we do, before we move things too drastically, let's put a breakpoint in here, and let's look around a bit. Okay, so our offset to this is now D8. Well, that's pretty big. So it's minus 40, and minus 40, and then we look in our class. Where's our class? Here. Class is 8. Actually, hold on. We can just take this. There we go. Okay, let's look at the base classes. There are two base classes. One is at offset 0 and the other is at offset 40. Yeah. So if we now look at the symbol address, copy value, we have one virtual thunk. Okay, good. Let's check the next one. Let's check one. Let's check one where we have more base classes. So here we have two. Actually, let me go to vtable for update module, yeah? Vtable for update module. There we go. No. There we go. So this one has 1, 2, 3, 4 virtual table thingies here. Update module. Update module. Let's go to here and we put a if class name equals update module. Okay, I wanna step in there and look at it. Int a 0, put the breakpoint. There we go. There we go. Update module. Okay, there we go. Good. So class index is this update module, and it has 2 base classes. Okay. Has 2 base classes. With 14 and 0. 0 and 14. 0 and 14. Mm-hmm. 0 and 14. 0 and 14. So if we look at M classes, C and Jesus. M classes 0x12. What the hell is that? Okay, there we go. Okay. So this one has no base classes, but this one has 2 base classes, and we are looking at 10. 10. 10. And then one of these probably has another base class. Like this one, maybe 13. Let's look at 13. 13. Object module. No? What about this one then? 14. 14. No? Okay, so I see 0, 14, and 10. What do we see here? Here we see 10. 10. Here we see 14. And here we see 4. Where's this 4 coming from? I don't know. I don't know where the 4 is. It must be somewhere. Mm. 10 is here. 14 is here. But where's the 4? There's a 0. C. Thirteen, 14. Thirteen. Ten. I don't know where the 4 is. Snapshots. It must be somewhere. I just don't see it right now. Let's go. Yeah, let's look at type info for update module. Yeah. Type info for update module. There we go. This one. That should give us. Oh, it's type info name. This one. There we go. There we go. Okay, that is offset 4 is snapshot. Offset 10 is behavior module interface, and 14 is update module interface. Yeah, and it should be somewhere in our data. Yeah, I just can't see it right now, but it's probably there. Yeah. Okay. Okay, I think what we need to do is we need to say Actually, yeah. Yeah. Oh man, things are getting complicated here. Um, hold on. Module, object module, object module, object. Why does object module not contain base classes? Is that an error? Ah, we are still parsing. Oh. Oh. Yeah. Right, it's because we're still in the middle of the RTTI parsing, so we may or not have visited the other thingy yet. Yeah. Yeah, yeah. Okay, that could be. Okay. What do we need to do? How do we store this? I think we need to. I think what we need to do is. I think what we have to do is have a vector of vtables, right? A vector of vtables. And then here we say int 32t offset to this. Or offset. How do we call this in a base class? Base offset. Then we just call it just offset 0. Let's put it here. Offset. Maybe we make it uint 16t offset offset in bytes corresponding to base class base offset. Okay. Okay, and the vtable entry here, we probably need to add a index t thunk index invalid index. Okay. And now this will be interesting. If our vtable can contain this, then this is no longer enough, or is it? Oh. 0, 1 get vtable entry. What does this do? Functions get. Yeah, I think we do we have thunks to destructors? Maybe. We worry about this later, I guess. Yeah. Okay, so offset and bytes. I wonder if we should also link here to the base class. Difficult. Make all right. Okay, here we say vtable entry dot thunk index is also invalid index. Then we do the same down here. And then here we do const and so we do it second function index invalid index and name is thunks name. thunk. I think we can remove this. Okay, then we need to say vtable. Yeah, I think we need to have a vector of vtables, essentially. Yeah. std vector vtable vtables. Okay, and then here we say let me think. How about we just put it up here? Put cons, no, vtable and we put this dot vtables how about we say vtable count. How about we rename this to vtable count is okay. Then we say this vtable count -1. Or how about we say m classes class index dot push back m place back class index m place back. How about we move this down here? We say here m vtables m place back. Then the vtable will be this vtables dot back. There we go. And then we put here vtable offset is 0. Well, I think the default is already 0. I think that's good enough. Can remove it. Okay, and then basically what we do here is once we hit this departure here, then we do the same thing again. We push back we emplace back a new vtable, and then we save the pointer here. There we go. Classes, class index, vtable, emplace back. There we go. Okay. And then here we simply do vtable, entries, pushback. There we go. There we go. Okay, this should work. Okay, let's stop debugging, see if it compiles and runs. If it does, I think then mission is done for today. Then, okay, we have good compile hours. Ah, okay. Yeah. Yeah. Yeah, we need to rethink this, all of this. For now, let me just write vtable 0, which would be the previous behavior. Right. Then here we simply say if class type vtables dot empty, then continue. There we go. There's still one more, vtables 0. Okay, this should do. Okay, let's see if that works. Actually, hold on, we forgot one thing. We forgot here. By the way, we should probably split this into 2 functions here. Type info vtable. Okay, what I'm missing here is here we need to save the vtable offset, right? Which I think will be minus offset to this. Minus offset to this. Static cast UN16T. Actually, how about we say assert minus this is smaller than 0x fff. Yeah. Okay. How about we put this assert up here? Ah, we put it on, yes, okay. Okay. Then let's put a breakpoint in here. Yeah. Let's see. Okay, there we go. Okay, so it's minus 40, right? Let's change it, minus 40. So vtables and place back. Vtable, there we go. Assert, this one is smaller than fff. And offset is 40, which is in hex 20. Hold on, 28. 28 classes. Watch classes, class index, base classes. 28, that is, yeah. Mm-hmm. 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 Okay. Mm-hmm. Okay, that works. That works. Maybe we should also have an assert here. Another one. Assert m base m classes dot m base classes assert. Oh no, I think that is not. I think that is not correct because there can be childs and childs. No, I don't think we can put an assert here, but we can probably put it later. Yeah, we can put it later somewhere. Yeah, I think this is fine. Mm-hmm. Okay, let's go through update module and see if it creates good data in there. Section end, vtable, vtables. Okay, vtable. Mm-hmm. Vtable. Mm-hmm. Mm-hmm. Okay, let's put a breakpoint in here. Yeah. So we expect four vtable counts, right? 1. Let's put a breakpoint here. So we have 2, 3, and 4. Yeah. Offset. Okay, I think this works, yeah? 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 So let's see what this class now has. Oh, we don't have a class index anymore. Ah, it doesn't matter. Okay, but I think this is correct now. Let's run this through. And what's hitting now? Okay, this one. Yeah. Okay, why is it accessing it? It's probably looking into the base classes. Yeah. Yeah, okay, it is erroring now, but yeah, we look into this in the next step. That's okay. I'm not too concerned about this right now. It's okay. Let it crash. Let it crash. Okay, let me look at the this point. This. So we have the thunks here. Let's look at our classes. 2100 classes. Let's look here into something here like damage module. Vtables 4. Yeah. Yeah. What do we have here? Thunk index. Thunk index. This looks good to me. And here we have some pure virtuals. Okay, looks good to me. I think the data is correctly pulled in. So that's good. Okay, then next step we need to parse it. Yeah, but I won't do this today. This is for the next session. Yeah. Okay, actually there's one more thing I would like to do. And that is simply split the big function there. Where is it? This one here. I would say we create a function parse thungs, parse type info, and parse vtable. There we go. I think that is the best. Parse type info. Then we make a copy of this thing. And then we put it here. There we go. There we go. There we go. And then here we say parse type info and parse vtable. Okay, it's pretty complex, but it works. Good. Then let's compile it. And we have some error. Vtable. There we go. Good. What's the time? Yeah, close to 2 hours is perfect to take a break. Got here some spam. Yeah, I guess I think he's working on some website. I guess you can accept him. Okay. Yeah, I think that's it. That's it. Good. Then, so this session, to recap, we did the we read in the non-virtual thungs. Maybe we need to do a bit more here. Maybe they're a little bit naked right now. So, for example, I wonder if we need to know if it's a virtual thunk for a destructor, for example. Right. Yeah, because here in our function we have a bunch of things. I don't know if we need the same here. Maybe we'll see. Okay. Okay. Yeah. So we added the parsing of the non-virtual thunk and the parsing of additional vtables. Yeah. Primary vtable in slot one at index. Primary vtable at 0. Secondary vtables with thunks to offset base classes at 1 plus. So at larger equal 1. maybe secondary vtables with thunks to base classes with offsets. Primary vtable at 0, secondary vtables with thunks to base classes with offsets at larger than equal 1. Okay. I hope that explains it. It's quite confusing. Okay. Okay, but now we have all the data that is here. Yeah. Yeah, yeah. Good. Good. Then next session we need to look into this stuff here and try to figure out how we use the secondary vtables to get the strides, the virtual function strides that we want. Yeah. It might be possible now. Yeah, we can also use the secondary vtables to get the names of the virtual functions. Yeah, of the pure virtuals, I think. Yeah, maybe we explore. We first write one function that goes. Yeah, we'll do the next session. No need to think about it now. Yeah. Okay, but this looks good. This looks good. Okay. And we should probably also start thinking about submitting our works. Keep on piling new stuff, but I haven't submitted for a while. This file is already getting quite large here, 1,100 lines. Bunch of commented stuff in there. It's getting big. Yeah. We need to simplify some of the things here. The buffer, I would like to get rid of this shit. Yeah. That's okay. Good. Also, these things, I think we should move it to another header file. These things here. Yeah. Good. Yeah, I will end it here at 2 hours. I wish you a great day or night. Until next time. Goodbye.